Hello everyone, this is lecture 26 for the quantum mechanics. In the last lecture, we have completed all the postulates of quantum mechanics. Now the main thing is that how we apply those postulates and how we apply all the things we have learned in the questions. So let's see. I give you this question. This is your wave function is given in its eigenstates, and these are C1, C2, C3. So what we need to do is, see here eigenstates are given as this. Means if you have phi n eigenstate, then corresponding eigenvalue will be n epsilon naught. Means for n equal to 1 means corresponding to phi 1 eigenstate it will be epsilon naught. For 2 it will be 2 epsilon naught. So these are your eigenvalues of energy. Now see what is the asking it is in the question. If the energy is measured on a large number of identical systems that are all initially in the same state psi, what values would one obtain and with what probabilities? So see, you have a large number of system. What we have, why we are having a large number of system? Because after operating the first time the operator on the particular wave function, it will collapse. So that's why we need a large number of systems on the same state so that we can just take all the observations. So if we observe all the possible means all the states, then we will get only these possible values 1 2 3 4 5. So only these 5 eigenvalues you will get, whether there was a very large number of identical system. So you will get only these 5 values. So we need to find out what is the probability that you will get one, you will get eigenvalue for epsilon naught or 2 epsilon naught or 3 epsilon naught. So you need to find the probability of that. So and then you have to find the average energy of the one system. Then you need to find the average energy. So if you have the probability corresponding to each energy, then you can find the average energy also. So let's see. Now here you can see h phi 1 will equal to 1 means epsilon naught phi n. So first what will happen means first you operate this operator on the wave function that will collapse to particular eigenstate. Then you operate in h on this, then it will give you eigenstate as 1 1 epsilon naught phi 1. So corresponding to n equal to 1. And it can collapse to phi 2 also, then it will give you 2 epsilon naught eigenvalue. If it can collapse to phi 3 also, it will give you this 3 epsilon naught. So these are the 5 possible states. So what is the probability? Probability is c1 square divided by ci square means sum of all. So these are the coefficient. If you can write this wave function as c1 phi 1 plus c2 phi 2, then this is the, for phi 1 it will be c1 square and sum of all the coefficients. So see, this is given in the question. So these are the coefficients c1 c2 c3 and c1 phi 1 c2 phi 2. So for c1 the square of this will give you 1 upon 19, and square sum of all these will give you 1 upon 19, 2 upon 4 upon 19, and 2 upon 19, 3 upon 19, 5 upon 19. That will give you 15 upon 19. So total sum will be 15 upon 19, and in the numerator we have 1 upon 19, so it will be 1 upon 15 because 19 will cancel out. So for the first one you will have the probability as 1 upon 15. Means to obtain this eigenstate epsilon naught, the probability will be 1 upon 15. For the second, it will be square of the c2. C2 will give you 4 upon 19 and divided by 15 upon 19 will give you 2 upon 15. Sorry, 4 upon 15. This will be your probability for the second state. Now you can find the corresponding 3 also. It will give you again square of this will give you 2 upon root 19. Means 19 will cancel out, it will give you 2 upon 15 again. So that's how you can find the probability for all these 5. And when you have the probability, now in the second part we have to find the average energy. So it will be energy multiplied by the probability. We have already discussed this, that how can we write the average thing in the probability terms. So E1 PE1 E2 PE2. So for all the 5 you will get this. So this is your total sum will give you your average energy, and we know E1 is epsilon naught and PE1 is 1 upon 15. So corresponding you will find everyone and it will give you 52 upon 15 epsilon naught. Now see what this probability represent. See, is means if you have 1000 identical systems, then probability is 1 upon 15 of 1000, that in the means in this 1000 1 upon 15 of 1000 will give you this eigenstate. That's what the probability represents. Let's take one more question. This is wave function is given 1 upon root 7 root phi 1 plus root 3 phi 2 root phi 3 phi 4, where phi n are the corresponding eigenstates and these are the coefficients c1 c2 c3, and Hamilton is given in this form h equal to phi n square epsilon naught phi n, where n represent the means there will be 4 eigenstates, so 4 eigenvalues will be there. For phi 1 it will be 1, for phi 2 it will be 4 epsilon naught. So that's how you can find the eigenvalues of h. So if energy is measured, what values will be obtained and with what probability? So again what we need to do, the same thing we did here. So to measure the energy and what the probability, so first we need to find that for 1 it will be epsilon naught and corresponding to probability will be C1 square divided by sum of all the C1 square, C2 square, C3 square, C4 square. So same as we did here, we will do here also. And corresponding you will get for 2 it will be 4 epsilon naught the energy, and for 3 it will be 9 epsilon naught, and for 4 it will be 16 epsilon naught. And then you will find the corresponding Ci, and you can get the probability. So before that there are two parts also. That's how you did the A part, so that's how you can solve this. So it is n square. So first, for the first one, if it collapses to the first eigenstate, it will give you 1 square epsilon naught phi 1, and probability will give you c1 square by ci square sum. So see here, if you take the ci square sum, it will be 2 upon 7, 3 upon 7, 1 upon 7, 1 upon 7. This will give you 1. So sum of all the coefficient is 1. So you just need only the numerator term, that is 2 upon 7. Square of this root 2 by 7 will give you 2 by 7. So the probability of first state will be 2 by 7, because this is equal to 1. Similarly, you can find for all the others. Like for the 2 you will get this, and probability will be this. Third it will be this, and similarly as we did in the last question, this is the same. Now the second part says that consider an operator A whose action on phi n is a phi n, and this operator operates on the phi n, and it will give you n plus 1 a naught phi n. If a is measured, what value will be obtained and with what probability? So as here it was defined, this is energy operator, but now this a operator is not defined, but what eigenvalues you will get, it is given. So for the n equal to 1 it will be 2a naught, and for 2 it will be 3a naught, for 3 it will be 4a naught, for 4 it will be 5a naught. So you have the eigenvalues, and so if you have the eigenvalues, you can find the corresponding c1 square, c2 square, c4 square from here. So you can find the probability for corresponding eigenvalues also, because this is operating on the same wave function. So you can do the say B part similarly as you did the A. So this is same to same. Now the C part is, suppose that a measurement of the energy yield 4 epsilon naught. If we measure A immediately afterwards, what values will be obtained? So you operate some Hamiltonian operator and you will get 4 epsilon naught as your eigenvalue. Means this will give you 4 epsilon naught only when it is n equal to 2. So it will collapse to phi 2 means. So when you operate H, it will collapse to phi 2. Then now we measure A immediately afterward. What value will be obtained? So this is collapsed to phi 2. So that's why, because here is 4, that's why we know this. Now we are operating this A on this phi 2. So this will give you the eigenvalue of this A on the for the 2, and for 2 it is n plus 1 a naught. So we know from this formula it is given in this. So it is operating on any phi n. This will give you n plus 1 a naught phi n. So for n it will be 2, so it will give you 3 a naught. So this will be your eigenvalue. Now this is your C part. Now for D says, if the system is initially in the phi 3 state, what value for the energy and A? What value for the energy and A will be obtained if we measure H first then A and A first then H. So what we need to do is, so system is in phi 3 and we need to measure, means what will be the eigenstate when we measure H first then A and then A first then H. So let's see first apply H on this. So H on phi 3 will give us 3 square 9 epsilon naught phi 3. Now operate A on this, so it will give you 9, so it will be 9 plus 1. Sorry, A is applying on the 9 epsilon naught phi 3, so A will operate on the phi 3. This will give you 3 plus 1 4 using this, n plus 1 a naught, so it will give you 4 a naught. Now 4 a naught multiplied by 9 epsilon will give you 36 epsilon naught a naught phi 3. Now similarly, if you see, if you operate A on the phi 3 first, it will give you 4 a naught, then 4 square will give you, means 4, and the phi 3, then H operating on the phi 3 will give you 9, so it is again 9 for the 36 epsilon naught a naught phi 3. So you will get the same value. Now there is another question. Consider a physical system whose Hamiltonian H and initial state psi naught are given as. So initial state is given and Hamiltonian operator is given in the matrix form. What value will be obtained when measuring the energy and the what probabilities? So if the matrix is given for the operator, you just need to find the eigenvalues that will give you the corresponding energy, because this is the energy operator Hamiltonian. So corresponding eigenvalues will give you the energy eigenvalues, and probability you can find the similarity as we are measuring by calculating the C1, C2, C3. So here it is 3 into 3 matrix, so we'll get 3 eigenstate and 3 eigenvalues. So to calculate the C1, C2, C3, we will use this initial wave function. So let's see how can we do that. And then we need to find the expression value of H, that is average H. So first find the eigenvalues and eigenstate of S. So we just need to do is H minus lambda I. So just how you solve the matrix, that's the simply you will get E1 as, means 3 eigenvalues will be there. So First is epsilon, and the other two will be same, that is minus epsilon. So to now you need to find the corresponding eigenstates. So for the epsilon, let's assume this is your eigenstate a1, a2, a3. So ha will be epsilon a. So let's assume this is equal to this. This similarly as we find the eigenstate in the matrix. So this equal to this equal to this equal to this. From here a3 will came out to be 0, and a2 will be minus I a1, and a1 is as it is. So just take the a1 out, or you can just take it as it is. So this will be your eigenstate a1 I minus I a1 0. Now to find the value of a1 means to normalize this, we need to take the conjugate transpose. So this minus I will convert to plus I a1 0. Now the dot product, this is inner product, will give you 1. So from here you can find that a1 will be 1 upon root 2. So a1 will be 1 upon root 2. So a2 will be minus I by root 2, and a3 will be 0. So you have your first eigenstate. And similarly you can find for the second, means for the minus epsilon, there will be two means these are degenerate states. So you can find the eigenstates for these also. This will be 5 2 and 5 3 will be this. You know from the matrix lecture, my mathematics lecture, means the mathematical physics, you know how to find the eigenstates, you can do that. So these are your eigenstates for the 5 2 and 5 3. Now psi can be written as c1 5 1, c2 5 2, c3 5 3. And if for the corresponding phi 1, it will collapse to means the energy eigenvalue is epsilon. We know for the phi 1, we already did this. And the probability for the this will be ci square c1 square divided by sum of all the ci square. So first we need to find the all the c1, means all the coefficients first we need to find. So what are the coefficients? This formula is phi 1 and psi. So this is the inner product of phi 1 and psi. So you have phi 1, we have find it here, the phi 1, and the psi is given here. So we need to find the inner product of these two. So this will be phi 1 is this. So take the conjugate transpose, this will give you 1 plus I and 0. So this will be your value, and this is your phi given. Now take the product, this will give you this, and this is 2 upon root 10. So this will give you 2 upon 5 under root 2 by 5. Now c2 similarly you can find, it will give you 2 upon 5 under root and 1 upon 5 under root c3. So now you have the complete eigenvalues and eigenstate and all the coefficients. So now you can find the probability. For the first epsilon, it will be c1 square by ci square. So sum is already 1, you can see. 4 upon, means 2 upon 5, 2 upon 5 and 1 upon 5 will give you 1. So only c1 square will give you 2 upon 5. So the probability of epsilon will be 2 by 5. And now the other two I have the same eigenstates. So to find the probability of this, means these are degenerate. It will be c2 square plus c3 square divided by ci square. Ci square is 1. So this will give you 2 upon 5, and 1 upon 5 will give you 3 upon 5. So this is the probability for minus epsilon eigenstate. Now to find the average energy, this is just energy multiplied by the probability. So energy for epsilon, it is probability is 2 upon 5, and for the minus epsilon, it is minus 3 upon 5. So the average energy will be minus epsilon by 5. So that's how you can solve. Let's see another question. Consider a system whose Hamiltonian H and an operator A are given by the matrices. So Hamiltonian and some other operator A is given in this form. If we measure the energy, what values will be obtained? So this is the energy operator. Find the eigenstate and eigenvalue. This will be your means energy eigenvalues or the energy values and the eigenstates. And you can find the probability also. Suppose that when we measure the energy, now this B part is important. Suppose that when we measure the energy, we obtain a value minus epsilon. Immediately afterwards, we measure A. What values will be obtained for A, and what are the probability corresponding to each values? Now see, first we need to find the eigenstate and the eigenvalues. So you can find them. I am just writing them here. So you can write as psi as c1 5 c1 5 1 c2 5 2 c3 5 3, because there are 3 into 3 matrix. So 3 eigenvalues will be there. So eigenvalues will be 0, minus epsilon naught, and 2 epsilon naught. So these will be your corresponding eigenvalues, and corresponding eigenstates will be 1 upon root 2 1 1 0 0 0 1 minus 1 1 0 and 1 upon root 2. So you have the complete set. And now it is saying that this collapse to minus epsilon naught. So minus epsilon naught, this is collapsing to phi 2 means. So this is collapsing to h phi 2. This is equal to minus epsilon naught phi 2. Now see, this h and a are not means commuting. So these are not commuting. That's why h is not equal to 0. So now we need to change the space vectors. So we can write this a again in the form of, means we can find the eigenstates of this phi 2, means when this a operates on the phi 2. So phi 2 can be written as d1 chi 1 d2 chi 2 plus d3 chi 3. Means see, if you operate this operator on any phi, Then this will again can be written in the linear form, means this there will be three eigenstates corresponding to this matrix operator and the eigenvalues. So we can write that phi 2 as d1 chi1, d2 chi 2, d3 chi 3. So a will operate and this will give you now this a operator can collapse to either chi1, chi 2, chi 3. So if let's say it is operating on the chi1, it will give you a1 chi1, and similarly for the a is phi 2, and this can collapse to chi 2 also and chi 3 also, that will give you a1 a2 a3. Now you have this operators, you can find the eigenvalues and the eigenstates. So chi 1 chi 2 chi 3 will be your corresponding eigenstates of this matrix, and corresponding eigenvalues you can find easily. So those will be a1 a2 a3, those will be your eigenvalues. So chi1 will be this and chi2 will be this. You can calculate them simply, just you need to do the calculation for the matrix. A1 will be minus root 17a, a2 will be 0, a3 will be root 17a. So you have all the a and the chi. Now you need to find the coefficients to find the probability, because it was asked that what values will be obtained for a and what are the probability corresponding to each value. So values will be a1 a2 a3, so these values will be possible, the eigenstates. Now what is the probability corresponding to them? For the a1, it will be d1 square divided by sum of all the d, just like we have the c1 c2 c3, here it is d1 d2 d3. So sum of all d1 square plus d2 square plus d3 square, and in the numerator you have d1 square. This will give you probability to obtain a1. And similarly for d2 it will be 0, and for d3 it will be means for the 0 this will be d2 square divided by sum of all them, and for the a3 it will be d3 square divided by sum of all the d1 square d2 square d2 3 square. So that's how you can find the probability corresponding to each value. Now try to solve this question. Consider a system whose state and two observables are given. So states and two means these two operators are given and this wave function is given for this. What is the probability that a measurement of a gives -1, and let us carry out a set of two measurements. When b is measured first and then immediately afterward a is measured, find the probability of getting value of 0 for b and a value of 1 for a. So you need to do this question. I will give you the solution in the next lecture. Now we measure a first, then immediately afterwards b. Find the probability of obtaining a value of 1 for a and 0 for b. And a particle in this next question. So a particle in an infinite potential box with wall at x equal to 0 and x equal to a has the following wave function: 1 over root 5a sine pi x by a plus 2 by root 5a sine 3 pi x by a. So what you need to do is find the possible results of the measurement of the system's energy and the corresponding probability. Find the form of the wave function after such measurement. If the energy is measured again immediately afterwards, what are the relative probability of the possible outcome? So try to solve them. There is one more question can be framed here, that calculate the uncertainty in A. So you can just calculate the uncertainty. How? Means you know the formula for the uncertainty. Uncertainty is nothing but simply just you have the variance, and the under root of variance will give you. So that is called the standard deviation, and we know the formula for that, that is under root mod x square, means under root average of x square minus average of x square. So that is, in place of x you will just write the operator, and that's how you can find, means here you can find the average value of a, and then you can just place that inside the formula and you can find the uncertainty. So that's it for today. Try to solve this question. In the next lecture we'll discuss these questions, then we'll move forward to further questions. Thank you everyone.